Okay, in the video today, we will try to do an exercise on chi-square. So we have a situations that we have two categorical variables. The first categorical variable is gender, the second one is social media. So we want to investigate whether gender and social media preference in a university is related. So we are given two hypotheses. The first hypothesis, or the null hypothesis, mentions that the gender and the type of social media are independent, or the two categorical variables are not related, meaning that the use of social media does not depend on the type of gender. Whereas for alternate hypothesis, the statement is gender and the type of social media are dependent or related. So you want to investigate whether we can reject HO or we cannot reject HO. So the best test is to apply a chi-square test since it involves two categorical variables. So what I have now is a sample of students, 50 students in a university with their gender and their social media that they like. For example, for student number 1, who is a male, he likes to use Facebook. And for student number 3, who is a female, she prefers Instagram. So by having this sample, we can now test the hypothesis by using a chi-square test. The first thing is, the first step is to create a pivot table for cross tabulations between gender and social media. We want to look for the observed frequency. So a pivot table requires us to select the range that we want to include. And I would like to have my output in the existing worksheet. So let's put it here and click OK. So in the pivot table field, I would like to have gender in the rows and social media in the columns. And I also would like to have social media as a count of values. So the output will appear like this, where I have the cross tabulations between female and the use of social media. Sorry, the cross tabulation between gender and social media. So the second step, before we go into the second step, I would like to create three types of table to make it easier for me. The first table is an observed frequency table. The second table is expected frequency table. And the third table is to calculate the chi-square value. Okay. The first table here, which is the observed frequency, is actually the same table as the pivot table. So just create a table with the same structure of columns and rows as in the pivot table. So I will copy the whole value here in the pivot table, and I will paste the value into my table which I just created. Let me try again. Copy. Paste. Okay, so now I have my table here, observe frequency. So we have completed our first step. The second step is to calculate our expected frequency. So remember, the formula for to calculate expected frequency is grand total of row grand total of column I just don't put the equal sign times the grand total of Is it column? Let me check it again. Okay, grand total of row times grand total of column divide by total number of observation. So this is the formula to calculate the expected frequency. Okay, let me show you how to calculate that. Okay, for Facebook and female, I want to calculate the expected frequency for female and Facebook. So the formula is equal to the grand total of row 1, which is here for female, times the grand total for the column Facebook, divide by total number of observations. So you get the value of 7.84. So just repeat the same thing again for the rest of the other cells, equal to the grand total here for female times the grand total for Instagram, divide by total number of observations, 12.32. For Twitter, grand total for female times the grand total for Twitter, divide by total number of observations, 7.84. For male, equal to the grand total for male, 22, times grand total for Facebook, divide by total number of observations. For Instagram, grand total for male times the grand total for Instagram, divide by total number of observation. And the last cell here, total number of male times grand total for Twitter, divide by total number of observations. Okay, in order to double check whether your calculation is correct or not, we can look at the grand total here. The grand total here should equal to the grand total in the observed frequency. So just select the whole rows here and look at the grand total. So the grand total for expected frequency equal to the grand total of observed frequency. So you are on the right track. So check for male. Also similar, 22. How about the column? 14. For Instagram, 22. And for Twitter, 14. And you should get here 50. Okay, so you are on the right track. So you have completed 2 steps. One, you have done your observed frequency. Second, you have calculated your expected frequency. So the third step here is to find the chi-square value. So in order to do that, you have to observe the formula of chi-square here, which is equal to the total of, in bracket, observed minus expected frequency to the power of 2 divided by expected. Let me show you how to do that. So we start with the first cell for female. It's equal to, since you have power here, the power of 2, your Excel formula, you should type power. Okay, power. So you have open bracket here. So open another bracket. So now look for the value observed for female here, minus expected, close your bracket, comma. Now you have to insert the power. Remember the power is 2, close bracket, divide by the expected frequency. Okay. Enter. Let's see. Yes. So you'll get 0.03. So just copy and paste the formula for the rest of the cell. Okay, In order to find the chi-square, you need to look for the grand total of both the column and the rows. Okay, for Facebook, the grand total here should be 0.13, and for male, the grand total here should be 0.16. So drag the whole thing here and look for the chi-square value. So now we have obtained our chi-square value, which is 0.29, roughly 0.30 or 0.297. Okay, so we have two approaches here to test our hypothesis. First is to use the critical value approach, and second to use the p-value approach. So now we have to do our decision making whether to reject or to accept the null hypothesis. We start with the critical value. So the formula, the Excel formula for critical value approach, to find the critical value is equal to CHI chi SQ dot INV dot RT. So that is the formula, the Excel formula. Chi-square dot INV dot RT. So in the bracket, you need to insert the probability and the degree of freedom. So you need to know the probability and you need to know the degree of freedom. Okay, how do you know what is your probability? So your probability is actually the significant value, which is 5%. And the degree of freedom, now I will show you how to calculate the degree of freedom. The formula for the degree of freedom is R minus 1 plus R minus 1 times C minus 1. What is R? R stands for row and C stands for 1. Okay, R minus 1. How many rows do we have? We have female and male, 2. So 2 minus 1 equal to 1. So for column, we have 3 columns, Facebook, Instagram, and Twitter. So 3 columns, 3 minus 1 equal to 2. So now the degree of freedom is 1 times 2 equal to 2. So we know that we now know that our degree of freedom is 2. So now we can complete our formula. Remember, the formula for critical value is equal to chi-square dot INV dot RT. Oh, I think I've inserted the wrong formula, sorry. Let me go back here. Wrong formula, sorry. Equal to chi-square dot INV dot RT. So you need to insert the probability, which is 0.05, comma, and the degree of freedom, 2. So the critical value is 5.99. So now we can compare the critical value with the chi-square value. So you know now that the chi-square value, or x2, is 0.29, is smaller than critical value. So if you look back on the slide, if your chi-square is less than the critical value, fail to reject HO. But if your chi-square is bigger than the critical value, you reject HO. So now your chi-square or the chi-square value here, 0.29, is definitely smaller than the critical value. So what is the decision? Fail to reject HO. Okay. And the second approach to do your decision making for chi-square is to look or based on p-value approach. Okay. The p-value. So now we look for the p-value. So the Excel formula for that is CHI SQ dot test. Okay, chi-square dot test. So in the bracket, you need to put the actual range and the expected range. So what is the actual range? Actual range is actually the observed range, which is the whole range for female and male. So put a comma, and the expected range is the range in the expected frequency. So you have completed both the expected range and actual range, and just click OK. So the p-value is 0.86. So the rule for p-value, if the p-value is smaller than sigma or the significant level, what is the decision? The decision is reject HO. If the p-value is bigger than sigma, you fail to reject HO. So now look at the p-value and compare with the probability or the significant level. So 0.86 is bigger than 5%. P-value is bigger than sigma. So your decision is p-value is bigger than sigma. So your decision should be you are not able to reject HO. Okay. So the critical value approach and p-value approach are both consistent, where both need or both cannot reject HO. So based on critical value approach and p-value approach, you are not able to reject the null hypothesis, meaning that the null hypothesis is the true hypothesis. So your conclusion is gender and social media are not related. Okay, not related. In other words, gender and social media are two independent variables which are not related. The use of social media by students is not dependent on the type of gender. Whether the student is a male or the student is a female, it is not related to their preference for social media. Okay, thank you very much.